Hey guys, welcome. One of my students asked me to make a video on graphing quadratic functions. Here is the first example. We did this in class as well. So when you look at this equation, first thing you have to do is compare this equation to the standard form of quadratic functions. So here is the standard form. It's y equals to ax squared plus bx plus c. So the first thing before we graph this is to compare the standard form of the quadratic function with this equation and see what are the values for these coefficients a, b, and this constant c. So a, the value of a is 2, as you can see. A is the coefficient of x squared, so a is actually 2. B is the coefficient of x, and coefficient of x in this equation is 4. C is constant. C is actually -3. All right. We got 3 values of these coefficients, a and b, and this constant c. The very first thing that you must do before you plot this graph is to see whether this graph will open upwards or downwards. So this is step 1. Does this graph open up or down? This value of a will determine if the graph opens up or down. If this value of a is greater than 0, which means if it's a positive value, then the graph opens up. In this case, since this is a positive value greater than 0, therefore the graph opens up. So graph opens up because a is greater than 0. In fact, a is 2. So the graph is going to open up like this. So we already know the shape of this parabola. The graph of a quadratic function, as you know, will be a parabola, and we know that it's going to open up like this. Step 2. Now step 2 is we're going to find out if this graph has the axis of symmetry. All parabolas have an axis of symmetry. This is the axis of symmetry, or the line of symmetry, because I can fold this graph, I can fold this parabola like the right hand side will overlap on the left hand side on this line of symmetry or axis of symmetry. So how do you find this line of symmetry and what's the formula for it? Here is the formula: x equals to -b over 2a. Now you can memorize this formula, or as I told you guys in class, that this is actually part of the quadratic formula which we're going to learn eventually in this section, in this unit. Here is the quadratic formula: x equals to -b plus minus square root of b squared minus 4ac, all divided by 2a. Or this can also be written as separately into 2 fractions, like this was one fraction and this is another fraction. This plus and minus part that is being added, it gives one point to the left of this axis of symmetry and the corresponding mirror image on the other side. All of these points have a corresponding mirror image points, except at this vertex. At this vertex, there is the image point and pre-image points, they are actually at the same location. There is no plus and minus happening at this point. So that's why we don't have this part, and that's why this is the equation for axis of symmetry. It passes through this point, which is also called vertex. Vertex is actually the maximum or minimum point of the parabola. So you don't really have to remember it if you know the quadratic formula. Since I did not teach the quadratic formula yet, but I was just trying to explain it to you, It actually came from this formula. So what is the value of b? B is actually 4. So let's substitute. Remember, whenever you substitute inside parentheses 2 times a So the axis of symmetry is that x equals to -1. Let me write it down. This one is the equation for axis of symmetry. It's that x equals to -1. So how do you plot this on this graph? This is the equation for axis of symmetry, x equals to -1. On this line, x is always going to be negative. X is -1 here, x is -1 here, y is 1, x is -1 here, y is 2, x is -1 here, y is 3, or x is -1 here and y is -5. So on this entire line, x is -1. And this line is called the line of symmetry or the axis of symmetry. The next point that we have to find out is the location of the vertex. And I just told you, while explaining you the axis of symmetry, the axis of symmetry passes through this point called vertex. It could be the minimum point, which in this case is, or the maximum point if the parabola opens downwards. This is also vertex. So how do you find the location of vertex? Remember, the vertex, the axis of symmetry actually passes through the vertex. So the formula for the x coordinate of vertex is same as the axis of symmetry. So x coordinate of vertex has same formula as the axis of symmetry, x equals to -b/2a, which we just calculated, x equals to -1. So we do know that the vertex lies on this line called axis of symmetry, but we don't know the y. Is it here, or is it here, or is it here? Or we're going to find the y coordinate of this vertex. So how do you find the y coordinate? We're going to substitute x equal to -1 in this original equation and find the corresponding y value. So the y coordinate, y equals to, I'm going to just substitute. Remember, whenever you substitute inside parentheses. So x is -1 squared. Now this one, hopefully you can do this mentally. This is -1 times -1, which is +1, times 2, just 2. This is 4 times -1, which is 4 times -1 is -4, and plus -4 is same thing as -4 minus 3. This gives us -5 because 2 minus 4, that's -2, minus 3, that's -5. So now we know the location of the vertex. It's going to be here. X is -1, y is -5. And we also know that the graph opens upwards. So we know the shape of the parabola is going to be something like this. The next thing we must find out is the y-intercept. And we can also find the x-intercept, but the problem is we did only factoring in class, the factoring method to calculate, to solve these equations when y is 0. Factoring is always not possible, therefore, or right now we'll be just finding only the y-intercept, because at y-intercept x is 0. So y-intercept is same as whatever is the value of c, which is -3. When x is 0, this is 0, and this term is also 0. So y equals to c, or c is -3. So our y-intercept, y equals to, or c equals to -3. So we do know that this is the location of the y-intercept. and there will be corresponding point here on the other side. So this is 1 unit away from the axis of symmetry. There will be a corresponding point on the other side as well. So we do know this part of the parabola. So as you can see that we don't need the points on both sides of the axis of symmetry. You just try to find the y value for x equals to 1. Let's say it is here. The corresponding y value will be on the other side, same distance away from the axis of symmetry. This is what we're going to do for plotting this graph. Let's plot the table of values. What happens? What's the y value when x is 1? Let's see. When x is 1, I will plug in x equals to 1 here and get the corresponding y value. One square is 1 times 2, that's 2, plus 4 times 1, which is 4. 4 plus 2, that's 6. 6 minus 3, that's just 3. So when x is 1, y is 3. When x is 1, y is 3. It's actually right here. Okay, now this point is actually 2 units away from the axis of symmetry. So there will be a corresponding point on the other side because parabola is symmetrical about the axis of symmetry. So I don't need to find out. So for x equals to -3, we do know that it's going to be, y is going to be +3. Let's see what happens when x is 2. When x is 2, let me plug it in. This gives me 2 squared, which is 4. 4 times 2, 8. 8 plus 8, 16 minus 3, that's 13. So when x is 2, y is 13, and it doesn't even fit this graph. So what I'm going to do is I'm going to just stop. I'm just going to connect these points, and this is going to be the shape of the parabola. Just draw a smooth curve passing through all these points. This is the graph of the quadratic function. Thank you so much. Bye-bye.